All right, so in question number 1, you need to find the area of that shaded region. And so what we're going to do is we're going to find the area of the circle, and we're going to find the area of that octagon, and then we're going to take the area of the circle and subtract out the area of the octagon, and we'll have our answer. And so for area of a circle, we have to use pi times the radius squared. And for us, that radius is 13.1. And so we get pi times 13.1 squared. Sorry, I gotta bring up my calculator quick. 13.1 squared is 171.61. And so that gives you an answer of 171.61 pi for the area of this whole entire shape, or the area of that circle. And I'm actually going to put that into a decimal quick. So I'm going to actually multiply this by pi. And that gives me 539.12. That's the area of my circle. They're the same thing on that second one. I just multiplied it by pi. All right, now I'm going to find the area of that octagon in here. I believe it's an octagon. 1, 2, 3, 4, 5, 6, 7, yeah, 8. So it's an octagon here. And then I'm just going to subtract the two areas to find my answer. Area of octo, I don't know, something like that. All right. And then this is where the problem gets a little bit longer, because the area of an octagon sometimes takes a little bit longer to find. And we do this by creating that triangle, finding the area of one triangle, and then multiplying it by 8. And so what that triangle looks like, it'll be kind of a triangle like this here. And we know that that part down here is 10. This is 13. And so I'll make that triangle. This is 10. The side length over here is 13.1. I just need to find the height of that triangle. I need also to find the central angle. To find central angle again is this part right here, and if I translate that down to my picture, that's this part right here. And so my central angle is 360 divided by my number of sides. So 360 divided by 8. I believe it, I'm going to check it on my calculator, but I believe this gives me an answer of 45. Yeah, and so we have 45 degrees as the central angle. When that gets cut in half, because the apothem there, that dotted line is cutting that in half, that becomes 22.5 degrees. And then I actually have enough to figure out what my height is. This apothem not only cut that central angle, it also cut this bottom part. So the bottom part used to be 10, but now it is 5 and 5 because it got cut. And so if I redraw this triangle one more time, this is now, that angle is 22.5. This side length down here is 5, and this part is x for my height. All right, well this, I have my angle right here. 5 is opposite, x is adjacent, and so then this is the tangent of 22.5 equals your opposite divided by your adjacent. So this is 5 divided by x. Put the tangent of 22.5 over 1, and I cross multiply. 1 times 5 gives me 5. The tangent of 22x, the tangent of 22.5 times x is the tangent of 22.5 times x. To get x by itself, I need to divide. So I divide by the tangent of 22.5 on both sides. And this gives me an answer for the height, because x is my height. Gives me an answer of 5 divided by the tangent of 22.5. Gives me 12.07. All right. I now can go back up and look at my triangle. It had a base of 10, and we just found out it had a height of 12.07. And so to find the area of the triangle, we have to do 1/2 times the base, which is 10, times the height, which is 12.07. This gives me 1/2 times 10 is 5. So 5 times 12.07 And when I do that in my calculator, I get 60.35 as the area of one triangle. And so the area of this triangle right here, is 60.35. But that octagon is made up of 8 triangles, 8 of those triangles. So we multiply this by 8. And what I get when I multiply this by 8 is 482.8 for an area. And so now I know I have my area of my octagon, which is 82.8. I have the area of the circle, which is 539.12. I'm just going to take my area of my circle, I'm going to subtract out the octagon, and whatever is left is going to be my answer. And so I take my, I gotta see my number again. 539.12. We're going to subtract out the octagon area, which that area again was 482.8. And whatever that answer is, whatever I get when I subtract that is going to be my answer for this problem. 539.12 minus 482.8 gives me an area of 56.32. And I don't know, is this in inches? I'll put it in the right. What is that? Feet. So that's feet squared because it's an area. All right. So that's really the idea behind that problem, is finding the area of the circle. The area of the circle is pretty easy. It's pi times the radius squared, and we know the radius. That problem just gets long because the area of an octagon takes a while. That's where you need to find that triangle, the central angle, find the area of just one triangle, and then multiply it by 8 because it's an octagon. But once you have the area of the circle and the area of the octagon, it's just subtraction to say what's left. All right. Number 6 here. I always see this as this is a sector problem. And so it's kind of like finding the area of a circle, but then multiplying it by the portion we have. And so what I'm going to do is I'm going to find the area of the entire thing. I'm going to find the area of this entire circle. And then I'm going to subtract away this portion that's unshaded. And then I'm going to multiply that by 40 out of 360 because that's just the portion I want. All right. And so to find the area of the entire thing, I'm going to call it area of big, because it's the big shape, or the whole entire circle. So the area of the big is going to be, and I'm going to erase these weird looking circles here. My radius for the big circle is 12. And so I'm going to do pi times 12 squared, because that's how I find my area is pi times radius squared. And that gives me, that gives me an answer of 144 pi. Now I'm going to find the area of the small one. All right. If this part right here is 9, that means this small part must be 3. And so I'm going to do, which means it has, that little circle has a radius of 3. And so the area of small is going to be pi times 3 squared, which gives me an answer of 9 pi. All right. And then what I'm going to do to find the area of the shaded is I'm going to take my big area, subtract out my little area. So I'm going to take 144 pi minus 9 pi. That's going to give me, and I'm using my calculator and I shouldn't, 144 minus 9 is going to be 135 pi. All right. And now what I've done is I'm going to try to draw it again. I have the area of this big circle. I have the area of this small circle. And now I've gotten rid of this small circle. And so what I'm left with is just this, and I'll put it in a different color. I'm left with just this area on the outside here, this blue part here. And so I don't want all this. I don't want this part right here. I don't want this. I just want that shaded part. And so what I'm going to do, that looks awful, but what I'm going to do now is I'm going to take my answer of 135 pi and I'm going to multiply it by the portion that I want. And that portion that I want is really this 40 out of the total 360. And so when I multiply that, I do 135 pi being multiplied by 40 out of 360, that portion. And this is then I do it on a calculator and I should have my answer. All right, so 135 pi is actually 424.1. And then that's getting multiplied by 40 over 360. I believe 40 over 360 reduces down to 1/9. So then what I'm going to do is I'm going to do 424.1 multiplied by 1/9. And that's going to give me an area of 41.12. And that's going to be my answer for that. Quick recap of that problem. Again, what I did, found the area of the big circle by taking my big radius, squaring it, multiplying it by pi, finding the area of my small circle, and really I could say that that is the unshaded part, and then finding that, subtracting the two, subtracting big minus little, and then taking my total area of those two of that circle, and then multiplying it by the portion that I want, which is the 40 out of 360. And when you actually multiply it out, you get 47.12 as your answer.